Let me, let me tell you something about Dr. Ravi M. Bhatkal, Managing Director, India Element Solution Incorporated, Cookson India Private Limited. Dr. Ravi Bhatkal serves as the Managing Director, India Element Solution Incorporated, Cookson India Private Limited. Dr. Bhatkal is responsible for the India businesses of Element Solution Incorporated, including McDermott Alpha Electronic Solution and McDermott Ethone Industrial Solution. Cookson India Private Limited is a unit of Element Solution Incorporated and NYSE listed 2.5 billion specifically material and chemicals company. He is also responsible for the Southeast Asia business of the semiconductor and Assembly Solution Unit of McDermott Alpha Electronic Solutions. Mr. Dr. Bhatkal earned a PhD in Material Science and Engineering and MBA from Rensselaer Polytechnic Institute, USA, and MS in Material Science and Engineering from Vanderbilt University, USA, and a BE in Mechanical Engineering from the College of Engineering, Pune, India, where he won the Savely Gold Medal. He is widely published and he is a co-inventor on 10 patents. Everyone, with the big round of applause, please welcome here for the presentation, Dr. Ravi M. Bhatkal. Everyone, give it applause.
Thank you all. Sorry to pull you back from lunch. Let me cover this quickly because I know time is short and everybody's waiting to go on. So we're about a $2.5 billion material science and specialty chemicals company. We're in 50 countries globally with 5,000 plus employees. Two major verticals or sectors: electronic materials and industrial and specialty materials. In India, we've been around for 92 years now. We started as a smelting operation way back in 1931 and have grown substantially obviously since then. We are the largest electronic interconnect materials company globally and in India. Our headquarters are in Chennai. We have global R&D center in Bangalore. We have manufacturing in Chennai, Bangalore, and Pune, and we have a technical test center in Manesar as well. In automotive, our key focus area is electrification, vehicle automation, and interiors and displays. Since this is more about EV and EV powertrains in particular, we work in the fields of power electronics, battery and battery management systems, and electric motors. And effectively, a simple way to think about it is we move electrons and phonons, and that about explains a bunch of things about us. So the key materials platforms we deal with are electronic interconnect materials, electrical conductor and interconnect materials, thermal interconnect and thermal management materials, protection materials, and reliability enhancement materials. So some of the, I won't go into this battery safety talk because we already talked about it. Some of the technologies we work in are encapsulation of battery modules, foams for fire suppression and management, thermal management of battery packs through thermal resins, thermal interface materials of different types, thermal management materials for stators in motors, encapsulants, potting compounds for onboard chargers, again thermally conductive materials to take heat out, and then getting into surface engineering for protection, electronic and electrical conductivity. So we have a business that's focused. We have a business focused quite heavily into coatings on a variety of substrates. In the case of electric vehicles, we would be doing nickel, palladium, silver, etc., all kinds of coatings on copper bus bars and connector surfaces, etc. And the it goes from cell level, adhesion promotion, current collection, conductivity enhancement, pack and module level, conductivity improvement, corrosion prevention, and then systems level at the inverter level for conductivity improvement, corrosion prevention, and wear resistance and shielding. Some of the examples for bus bar plating include rack, barrel, and reel-to-reel with nickel, tin, silver, copper, and palladium nickel. In terms of BMS and power electronics, I know that this is a really important topic in general. In power, you see the whole range going from low voltage to high voltage, especially in automotive. And the approaches range from having discretes and assembling those discretes on a board to having direct chip attach, building power modules off of that, and also doing mini modules. So we are heavily involved in this space, specifically in terms of two things. One is reliability improvement with very high reliability solder materials that extend the life very substantially in high thermal fatigue as well as high vibration environments. You almost get 2x the reliability relative to normal attachment materials. I won't go through this substantially. And then in chip attach to substrates, be it either silicon carbide or gallium nitride or even silicon for that matter, there's advanced technology now called sintering, which is used quite heavily. We've been working on it for more than a decade, but now it is commercial on a global basis. The idea is that you would bond a silicon carbide or gallium nitride or silicon material to a substrate at a low temperature using material like silver, but once it bonds, you get a high temperature performance out of it. And so you can run silicon carbide at 200 degrees C and have no problem with the bond in that case. The kinds of enhancements you get are, you can get 6x peak performance, almost 9x the power density, and 1/3 the weight reduction. So it's very, very substantial benefits. It actually improves a range when you actually implement it in high power electric vehicles. And this is commercial now and rolling out on a global basis. The other major platform is mechanical reinforcement and reliability enhancement using what I would call underfills, edge bonds, and adhesives. And this, coupled with high reliability solders, can give you super high reliability, highest reliability that's out there available. And these are just some data points for that. You can get 3,000 thermal cycles minus 40 to 150, which is very, very harsh thermal cycling requirement. So I'll wrap it up here, just say that there's a full portfolio of materials. I mentioned this last during the panel discussion, that you can actually look at anywhere where an electron goes you map it out and enhance the efficiency and manage the conductivity as well as the thermal dissipation using these advanced materials. So with that, I'll conclude, and any questions, feel free to ask later on. I know it's a little late and everybody is waiting. So thanks a lot for your attention. Thank you.